So at about noon today, I was at a good stage and everything was going along according to plan. Actually, by about 11:30 today, things were going to plan. And then I ran into this one little glitch. And what I wanted to do was I wanted to be able to have this nice little animation up and running showing how the actuators right here, we've got a motion link between these syringes and these syringes up here so we could see the whole bucket go through here. And I wanted to be able to show you that everything was going to work. And before we started building the final parts, I wanted to know for sure that everything was going to work. And then ran into one little problem. And I know after talking to many people as they're learning Fusion 360, they tell me about the difficulties and the challenges that you run into. And I want to assure you that I totally understand because I've spent the last 6 hours going to help forums and tutorials and everything I can to try and solve one obscure little problem in my design. Now, now that I'm back in Fusion right here, let's see. We'll activate this screen here. Okay, there we go. And now we've got some motion and control over here. So what we've got is we've managed to put together our excavator structure. And as you can see, I've made this out of sheet metal. I've made it a little wider than we need it to be in terms of the arm because that's a little wider than the syringes are because I measured the box and pan brakes that we have in at BCIT. And if we want to be able to fold those up nice and easily using the equipment that we've got available to us, in order to get that kind of depth, we need that kind of breadth to fit it around on the box and pan brakes. And I can show you what I'm talking about in just a minute. But I think today, rather than now that we know this structure works, I'm going to show you how to put together the boom and the arm using laser cut parts because we should be able to take a piece of MDF, drop it right in there, cut a couple of pieces to fit into the middle, and build a part that would just drop right in and replace this part right here. Now, there are some structural issues with this design, things that I'm looking at right now that I really don't like. Buried away down inside of here, and let me well, we can't quite see from right there or from right there. You can see the pit profiles out here, but buried inside here, we've got a dowel sticking up, and this piece right here pivots back and forth on the dowel. And although you're going to be able to move that by hand, so using our contest rules, so I guarantee that it'll be able to move. Um, I think we need a taller dowel or a sturdier dowel or some kind of better base right down here because when you look at this from the side and that arm is stretched all the way out like that, okay, and you go to turn that, you've got this huge lever arm, hopefully a bucket filled up. Well, your plastic beads aren't going to weigh all that much, but you're going to have water in this syringe out here, and this is going to be tilting down right here, and everything's going to be resting on this front right here or on your pole right coming up inside here. And if that was a little bit taller, maybe back here, or maybe if we had something smoother, or even a little roller mounted right down here inside the front so that we didn't have sliding friction, but we had rolling friction, things would all be okay right out there. So there's our pit profile, and you'll recall a couple weeks ago we made some control boxes. Now I went back and edited up the control boxes, and if you want something to do right now, I recommend maybe going back and doing that because what you're going to want is you're going to want one control box with a 10 milliliter syringe mounted in it really nicely, one control box with a 20 milliliter syringe mounted in it really nicely, and one control box with a 30 milliliter syringe mounted in it really nicely, because your 30 milliliter syringe is going to control your 30 milliliter syringe out here. We're going to use something called a motion link so that when you come in here and activate these controls, your arm will pop up and down just like that. And that actually, looks like it's working really good. And it sort of is, except for one little thing. And this is what kept me occupied for the last 6 hours, because it's one of those things that if you're going to set up a tutorial and there's one little thing going wrong, it probably means that there's more than one little thing going on in there. And you see right here, I'm only moving one syringe right here, but I'm getting this weird random movement from these other two syringes right here. And when I'm just trying to open and close the bucket right there, it's driving me nuts that this arm right here is also actuating. And yes, I see, it just shouldn't be doing that. I can fix it. I can come back in here and pull everything back in, but that is a little glitch that um, I'm sure somebody who wrote the Fusion 360 software is going to be able to tell me exactly what's going on, and I am going to have to post it to a help form. But before going and asking for help on a help form, I do like to make sure that I've spent a good amount of time searching for things. So anyways, it's working pretty cool. And we can come down here and we can pull this out, which drops that down, and we can drop this down in here a little bit, and we have to play around with all of these, and eventually we can get it into the position that we want to dig up some dirt from inside the syringe. These ones, I can get this one to come up. And ended up trying a whole bunch of different things. One of the things you can do to go in there, and a different way to maneuver these things around, is to use the drive joints command. So if you've got a joint that's misbehaving in here somewhere and you want to take a look at it, let me come up here to our joints. So this is our excavator assembly made out of sheet metal. Here's all my joints. I've got a whole bunch of rotational joints. Rev 1 right here, if I want to drive this joint, I can come in here and Rev 1 just spins back and forth from side to side. Leave that sitting at 0 degrees. Rev 2 right here, if I want to drive that joint, just click on OK right there. Rev 2, I can drive that joint, and as you can see, as I bring that down, that forces the other joints right here into position. I can come in here, I can take a look at my arm to boom, and I can drive that joint right here and bring that down to make sure that we're getting a full range of movement. And we're almost scraping the bottom right there. Let's bring it down a little bit. We're sitting right there. And so we can say OK on that one. And then the linkage to arm, I can drive this joint right here. I'm right clicking to get the drive joint feature, and I can bring that up. And it's just really bugging me. Like you'll notice as I do that, this arm, this syringe right here is also moving, and it shouldn't be. So we're going to be able to come in and scoop some things up like that. We might need a slightly different bucket design. I've designed this one so that it can be 3D printed, but you can make one out of sheet metal. There's all sorts of different ways that you could make a bucket like that. And then once you've scooped that all up, of course, we can say, okay, then you can come back over here, lift this up. Better stretch that out so we don't go into the wall right there. Lift that up, pivot it over to your weighting, and that wasn't supposed to happen. Pivot it over to your weighting vehicle. What happens if I undo that? There we go. Yeah, see, so when we're getting a little bit of glitching right in there, that's just a sign that there is a little bit of a problem going on. And yep, now that's gone over past center, which is actually a possibility when we look at the arrangement of how the linkage is set up in there. And you could play with that geometry and your parameters a little bit. But anyways, so that's the sheet metal version of it. And that was my prototype version, just to come through and make sure that I'm not leading you all down a garden path. This actually does work. If you want to get really, really, really fancy, you can draw lines that come around here, connect them at various points, and extrude or sweep a shape along them so that you can even get the tubing connected to the syringes. But we're not going to go quite that far into the detail. We'll assume that you just have some nice tubing runs set up and ready to go. So anyway, this is where we're heading with all of this, and hopefully by the time we get to the point where you're putting together your boxes, we've got them all working nicely, and you're able to see everything come together. There's definitely going to be some opportunity for customized design on here. You should already have some customized parameters for your linkage and where you want your bucket to bolt on. You're going to design your own bucket of some kind, and yeah, I'll show you some tricks that let you take your profile right here and extract that and make yourself an arm. Now, one of the things that you have to keep in mind is that you've got to think about which sides and what measurements you're going to be on right in here. So as you're designing things, if you ever need to get a measurement and say, well, how big do I make something? Remember that you can come up to the inspect button, click on it right here, click on one surface, click on the other surface, and you can get an inside measurement of 57 millimeters right there. Or if you want to get an outside measurement, you can click on the outside and click on the outside and get an outside measurement of 57 millimeters right there. Now, those of you who've spent time building things in the past, you'll congratulate me on my marvelous CAD skills, because I did what everybody does when they design using CAD. And I said, well, if it's 57 millimeters on the outside, I should just make it 57 millimeters on the inside. In reality, there may be tolerances in your manufacturing. We have very fine tolerances in CAD, and everything fits in here and slides together really nicely. But if you happen to make this 56 millimeters from outside to outside, and this 57 millimeters on the inside, and left yourself a little bit of slop, that would probably be a wise design choice. So we've got a few neat things coming together in here. As you can see, I haven't gone through and put all the nuts and bolts and screws in yet. That's just a matter of time. I do have, where did I put some of them in? Right over here. Yeah, I put them in right there. Now, one other thing that I noticed as I was putting these control boxes down on the baseboard right here is that I just magically jointed them in place. And if you look inside those control boxes, you can see that there is absolutely nothing holding them to that piece of wood. And depending on how you want to put them down, I'm thinking that, because you always have to think when you're drawing CAD, how are you going to assemble something? And I'm thinking that the way to assemble this is to put each of these boxes together. And in fact, I'm going to recommend that you go and you build those boxes in CAD separately. But when it comes time to put them onto the base right here, they'd probably work a little bit nicer. You can probably fit a screw down inside here, maybe a second screw right inside here, but they'd probably be nicer if you put a little flange that came off this side right here and just drew that in. And it could be square, but round would be really nice. That could be rounded off right there, and just space for a screw hole right there. And then looking at the back, what if you just folded a piece of sheet metal down right over the edge right here, so it came in and just covered right down in here, and then you could drive a screw, very small screw in this way. It's not going to take much, but that would enable you to take that piece, pop it on there, and if you ever need to change it out, then that screw is accessible and that screw is accessible. Yes, you could come up here, you could undo these two screws, swing the syringe out of the way and get a screwdriver into the middle to put two screws into the middle. But when you're designing this part, you probably want to think about leaving yourself either a couple of holes inside right here so that you can pop that up, take those two screws out, flip that out of the side and put that in and out. Or you probably want to put a couple of flanges down here so you can dismantle the whole thing a little bit easier. So a few design elements in here as we go through it that we do want to keep in mind. And yeah, but by and large, it looks good. I think it's going to work. And as I was researching this and looking at help keys, answer keys, oh my goodness, did I check out a lot. Is there a way to make joints stay locked or unlocked? I can't tell you how many different help files I went through, but I can tell you I did come across somebody else who's been doing almost the exact same project, and they've posted a nicely rendered wooden arm right in here. And so as you can see, these concepts can be used to manufacture arms in a number of different ways. They've rendered that one up really nicely, all out of wood from a few different viewpoints in there, different way to mount your syringes. And because Fusion 360 is all cloud-based, you can actually come in, and after you've created your model, you can come in and you can share your model right in here. Unfortunately, it's not really interactive, but yeah, if you search for Fusion 360 and Excavator, you'll find that we're not the first people to have done this project. Actually, there is a YouTube channel, and let me just see if I've still got that one up over here. And Fusion 360 Excavator. I'll just search on my opposite screen right here. And there is several people with excellent tutorials out on YouTube. Some have done it a bit more than I have. And here we've got somebody who goes through and creates a nice model of an excavator in Fusion 360, but he doesn't activate all the joints and make them work independently. So I'm a little disappointed in that tutorial. But if you go to his channel, his name's Sparkplug down here, and you can see he's got a Scara arm right in there that he's modeled and designed. And if we go to videos, somewhere in here, he's got some all sorts of interesting things that you can do in Fusion 360. Oh, there's a neat one. Be interesting to know if he actually made that. Some very cool joints. And down here, he's got a whole excavator tutorial, 1, 2, 3, 4, 5 parts that comes through. And by the time he's done in here, now if you're looking for a neat bucket design, I think that bucket might be transferable to what we're doing. And there's a nice tutorial on his channel how he makes it go together. You just need to use it with our project dimensions, of course. And there we go. He's got something similar going, although admittedly, I don't know how much effort he's put into thinking about how he's actually going to manufacture these parts. I think he's designing something that looks really cool, but they're not the easiest to manufacture parts for the high school shop environment. Not everybody lives in the high school shop environment. And oh, look, GCN, the cycling network. How did that ever show up on my YouTube? Okay, let's see right here. We've got this thing working. Let's go back to where we were and take a look at how to go about making this on the laser cutter. And today we're just going to focus on one part. We're going to take the boom and we're going to end up making a laser cut boom in Fusion 360. This is about where we were when we left off last day. We had a working parametric model and you'd been able to play around with all the different parameters so that your model would dig in nicely and you had a good range of movement using the syringes to scrape down into the pit. So we had our pit profile on there and you could spin that around, look at it from the side, and you could drag that out. And we didn't have the full bucket actuating right on there. And like I say, that's something I'm going to have to learn a little bit more about, how Fusion 360 manages multiple stack joints like that, because sometimes if you play with it, you can get Fusion 360 to pull that joint out, and other times it's just a bit of a pain in the butt. Anyways, so that's about where we were. And I can't remember if in our last tutorial we talked about how to fill in this side or whether we still just had circles around that side. If you've still just got circles around that side, this is your arm, and you can come into your arm and you can come into the sketch for your arm, double click on the sketch, and to make it become solid, all that I had to do was come in and I drew some lines because we had the 5 circles going around there. I drew lines from here to here, down to here, and along here. Then just to make sure they were all connected, I came back and put the tangent modifier on them, and that turned them into nice solid booms. And these lines come in here and meet at the tangent points. If they're not meeting perfectly at the circles, you can also sometimes get away with a coincident constraint to make sure that they do touch the circle. There's no law requiring that they be tangents, and there's no law requiring that you have this much meat around the outside right here. We just dimension that with a 24 millimeter diameter. I think we said it was the diameter plus 20. You could go back and change that to something else if you wanted to make it a little smaller and a little lighter. I am going to show you today, though, how we can take this and we can truss it out later on and end up making it a little bit lighter still. Okay, so if you don't have a solid piece right there, go ahead and where'd everybody go? Oh, we're all down here. Remember, you do have a zoom to fit command right here, so you can bring things up and zoom them right back into place. Okay, so now what we're going to do is I want to take this part out, and we're just going to take a look at the boom. If you have a nice solid arm, you can go and work on the arm too, but we're going to pop that boom out, and we're going to create a new part out of the boom. So if you highlight that, make sure that you come in here, find your boom. Yeah, that's the right part in here. And over here in your browser, just right click on the boom and go Save Copy As. Okay, so Save Copy As is going to take that part, and in your folder that you've been working on, I'm going to say this arm and linkage 2. So that's the name of the project that it's coming from. This is the component that's coming out. It's the boom, and I'm going to say for MDF. Okay, actually I should say 3 millimeter MDF, because we're going to make it out of 1/8 inch stock on the laser cutter. Okay, and that part comes out, and it should come up right in here as your most recent one, and you should be back to version 1 on here. And you can actually get rid of this file. We'll leave it open for a moment just in case we want to take a look at anything else, but open this part up. And now you have a nice, simple part right in here. This is the piece of MDF that you're going to use to create your boom for real this time. But before we begin, there's a couple of things to think about. So like I say, lots of things to think about, and the time to be doing your thinking is before you sit down in front of your CAD. You can puzzle some of it out while you're working on the CAD, but I really find that pen and paper works best for most people when they're doing design and thinking up their concepts. And before every time I sit down with CAD, I try to have a detailed plan of what I want to do and where I want to go. Now, this is what I had drawn out when I was working on the sheet metal components. And as I was saying, this is a side view of the box and pan brake, and I knew I wanted to be able to make them on the box and pan brake. So I went in and I measured the height and the depth of our box and pan brakes. And on the little box and pan brake that I have down in the electronics shop, So long as I'm 3 centimeters high, I can get up over the fingers right here, but I can only come 7 centimeters back before I start running into the brake. And that wasn't going to be big enough for some of our parts. However, if I go down to the machine shop, we've got a larger box and pan brake that if the fingers are 5.5 centimeters high, but that gets me a 13 centimeter clearance, and I should be able to fold a nice U-shaped piece with nice crisp edges out of sheet metal. So you'll notice that I made the inside measurement on my sheet metal. Everything was just over 55 millimeters. There's a lot of 57 millimeter inside right there. And you can see right down, oops, that wasn't what I wanted. You can see right down in here, I was trying to zoom in, but that was the wrong button. We've got a bucket that's going to go on the end. The bucket has to fit with the arm. The arm fits inside the boom. And on this sketch, I had the boom fitting inside the base and the base resting on a dowel. And I think I mentioned some of that earlier in the prototype idea of having your dowel come up here, but your dowel can't come up so far that it gets in the way with the syringe that's reaching right across there. And your dowel, if you build something kind of rectangular, it needs to be set back not by the face right here, but by the diagonal, so that you don't end up reaching over top into the work surface out there. So a few notes on here on when I was messing around with angles on the boom and all that. And in here, just a couple different ideas for how to make a bucket, because you can start thinking about how you want to make your bucket. That's a place where you can have a lot of individual innovation. I was thinking of this piece right here being, if I wanted to stick to the sheet metal theme and make this all a metal shop type project, you could get in here, you can punch a hole at each corner right there and use a little hacksaw blade or jeweler's saw to cut these edges out right here, fold each of these pieces up. Yeah, you'd punch your hole, of course, before you started making them, and then you'd be able to connect to those pieces right there. You could, of course, also use a piece of folded sheet metal and pop rivet in place, probably the quicker way to do it. And then I was thinking, well, if this was my flat piece here, these sides could swing up to make my layout, and I could swing that around, and I could almost make that entire shape out of one sheet of sheet metal. But while I was thinking about it, I thought, oh, well, I can also 3D print one. And so long as it's small enough to fit on the bed of the 3D printer, if I keep my angles on each side right here up to 45 degrees or steeper, then I shouldn't have to worry about too much about support material, even right here where it's going to end up being hollow underneath. So I decided to go with the 3D printed one, but your choice on how you want to go about making your bucket. I think you could make a nice one out of wood if if you had some nice block of wood up at the top, and we've got a lot of people who are pretty good at joinery. I think we could have some neat designs. Keep touching the mouse button. Okay, if you're watching the clock down at the bottom, you'll notice that we've just jumped ahead in time a little bit, which means I was swearing for a little while. I went about doing what I wanted to do in the non-optimal way. So let's come in right here and let's take a look at a more optimal way to do it. So let's drag this up right here, and we're going to create a sketch on this edge right here. And that whips off your screen. Don't forget you've got fit right down here. That brings things up and lets you see what you're doing. And we're just going to create a rectangle, and we're going to create a rectangle. We better project that surface onto here. Let's project that whole surface. We'll say OK, and then we are going to create a 2-point rectangle from somewhere on there to somewhere right there, and then we're going to dimension that, and from that end right up there to right down here, let's just make it, I don't know, 50 millimeters sounds about right. And from this end here to this end here, we'll make that 50 millimeters. Yeah, that looks like it'll probably do the trick. Leave us nice, lots of room top and bottom for holding things together. We're going to finish the sketch. And now what we're going to do is we're actually going to project this down and use it to cut a piece right out of here so that we can put a spacer that comes in over to that imaginary plane that we created so that we can piece these two apart. So what we're going to do is we're just going to extrude. We're going to take this surface, make sure you get just that surface. And the distance we want to go is downward, so it's in reverse, so -3. It's going to come down there, and it automatically figures out that it should be cutting right there. And we will say, okay, you go ahead and you cut right there. And now we've got a little space right in here, and we can finger joint a piece that's going to come across out to that imaginary duplicate plane right in there. So to do that, we're just going to come in here, and we're going to create a sketch right on this surface right here. Make sure that you come down and you get the new lower surface, because then we get all the measurement information from that. There we go right there. And check that out, maybe from an angle, make sure, yeah, you got that surface. And then you can make sure that you can project the dimensions of that piece right in there and go okay. And what we're going to do is we're just going to create a rectangle that comes off of there, comes down to the bottom. If you have to, just tap on right there and that should lock it in place. Bring it out to about there. And then let's add a dimension from this side right here into this side. Remember, we made that plane at the 22 millimeter mark from the inside. Let's bring that out 22 millimeters from the inside. Okay, let's finish our sketch. And now we are going to extrude that, but this one is going to be these two pieces, and it is going to extrude upwards 3 millimeters. Okay, now we are not going to join that. Be careful about what you do right here. We are going to create a new component in here, because we want to eventually be able to take these components apart and send them to the laser cutter, send their profiles one at a time. Okay, so there we go. Now that part is sitting right in there, and it is sitting nice and snug into the hole that we just caught. And to make it a true finger joint, what we're going to do is we are going to take that and we are going to extend it down this way just 1 centimeter so that when we put it together, it's not flopping around too much right in there. So let's take this and we will take this and extrude it on that side. So come in and activate component, well, come down to component 3, bodies, and body 1. We want to work on body 1. So let's activate component 3, and we are going to create a sketch on this surface right here. And we are going to project. We're going to project that line into it as well. Okay, and now we are going to create a 2-point rectangle from right there to right there. We will finish that sketch and we will extrude this out. And we don't want a new body. This one, we're just going to join it into the existing body right here. We'll take that out. 3 seems to be a popular measurement right there. So now you can see that when that slots in there, it's going to hold together pretty nicely. And then we're going to come over here and do the same thing on this side. And so sketch. And you're probably looking at it saying, hey, there's other ways that you can go about creating that. There's different ways that you can build things. And if you're saying that, that's excellent, because that means that your project's probably going to come out better. And as you figure out the software, I'm showing a relatively straightforward way to do it. I'll project that, and we'll project those 2 dimensions, and we'll draw this box right around here. But you know, there are alternative ways to go about doing this for sure. Okay, we'll finish that sketch and we'll extrude that out by 3 mm, not as a new body. We want to join that to the existing body. Okay, up, need to give it a distance. And you can bring it out 5 mm if you wanted. 3 mm works fine. Okay, there we go. So that comes out right in there, and that will end up holding holding that together. At that point, it'll hold things apart. Now, I think we also want to be able to hold this together a little further down right in here, because otherwise it's just going to flop about in here. We could put a piece right up along the top right here, although this is, oh, go back and activate our entire component so we can see the whole thing. We could have a piece right up here, although you're going to have a syringe right in here. I'm thinking you could do something similar right in here and put a piece. Now, if you've got any questions about where you can put that piece, come in here and take a look and say, where do I have nothing happen? Right in here, you've got nothing happening right in about here. So that's all good. Don't want to get in the way of anything right in here because that syringe might come through, but you do have a little bit of space to put another spacer right in here. Okay, so that might be a good spot to put another little piece of MDF. So you can come in here and again, what we're going to do is well, let's name that component 3. We should name that as spacer 1. Okay, and that's sitting right in there. Then we'll come in right here and we'll do the same thing. We'll cut away a little bit of space on this surface. So create a sketch down here. Okay, and let's see, where are we working? We're working right on that surface. That's good. Sometimes when we get into these views, I like to play around with my view a little bit, and I will project that entire surface into our sketch. I'll draw a box that comes in here, ties off that edge. Make sure I come out the same side. Actually, this one I'm just cutting away a piece, so it's only going to be 3 mm. I'll dimension it from this corner right here. I guess I'll go from that edge to, why am I not in the dimension tools? Sketch dimension, there we go. From that edge to that edge, and I'll make that 30 mm. And then I'll dimension it from this edge to this edge, and I'll make that 30 mm. And now what I'll do is I will extrude this piece down 3 mm. So I've finished my sketch. Extrude 3 mm in here. Where's my extrude? Extrude, distance, minus 3 mm. I am going to cut. Make sure it's got the right object to cut. The boom profile is getting cut right there. And we've just taken a chunk out of the boom profile. And now we can come back in here and do like we did at the top. We can put a, yeah, I'm fighting with my 3D mouse. We can come in here and we can create a new sketch on here. That's going to come in like so. And create a box. And I'll show you, we can get a little bit fancier right in here. Actually, before we do the box, let's do a project. Make sure we get that surface in there. Now let's create a box. And there we go. Come down, and that should link right on that bottom right there. Come out right over here. And again, we wanted it to be 22 mm on the inside. So we'll come right there and we'll say that's 22 millimeters. Now, like I say, you were probably thinking, hey, Jason, there's easier ways to go about creating that little flange at the top, and you're right, there is. Let's just do it all part of one big extrude. We can come right up there. We can add a 3 millimeter flange right in there, and we can add a 3 millimeter flange right in here. We can finish that sketch, and now when we go extrude, we can take this piece, and this piece, and this piece, and we can extrude that up 3 millimeters and make it a new component. Component comes in right here, and we'll call this spacer 2. Okay, now as we start doing this, everything kind of looks the same, and it's hard to tell where some of the joints are. We've got a couple more spacers that we need to build yet, and that can get a little bit challenging and a little bit fussy. Because it's hard to keep track of everything. And thankfully, I did find useful things out while I was stuck in my 6 hours of non-productivity today trying to figure things out. There were some good things. If you come to your inspect and go to component color cycling toggle, it turns all your different components into different colors so you can see which component is which and how they're all fitting together right in there, which is, I think, pretty cool. Okay, so let's see right now. We want to now get something that braces these so that they don't flop down all over the place. We want something that comes into the corner right here and supports that. So what we're going to do is we're going to come in right here, and let's create a sketch on this surface right here. So we'll come in and we'll create a sketch right here. And what we'll do is we will project the profile of this piece right there. There we go, right into there. And so we'll take that into there, and we'll have a couple of pieces that come down right inside here from that. And to make space for them, what we're going to do is we're just going to create a couple of rectangles. Now, I'm not going to use the rectangle tool because I want them to be perpendicular to things. So let me come in right here. And oh, look at that, that little blue bit right in the middle there. That is a sign that I'm getting a perpendicular icon in there. So I'm perpendicular to something. And then you see I've got a right angle icon. And then another right angle. And then I close that off, and I've got a shape right there. And I can dimension that up. And I can say from that side to that side is going to be a 3 millimeter groove. Okay, I can tell it that from this edge to that edge, I'm going to bring it in, let's say 5 millimeters down right there. And from this edge to that edge, watch the dimension that you're going to get. I don't want an angle. Ooh, see, that didn't come in perfectly parallel. That was why it was giving me an angle right in there. Watch your constraints. You do have a parallel constraint, and tell that to be parallel to that. And that should all be good. Constraint has already been applied. So it was in there. Okay, maybe just my eyeballs didn't think it was okay in there. Let's do a dimension. And put that in right here. We'll bring that up 5 millimeters, not 55, but 5 off the edge. And we'll make this. And again, you can either get an aligned dimension if you stay close to it, or if you kind of drag it up this way, you can get well, a matching dimension, and we'll make this 20 millimeters long right there. And let's make another one of these right down at this end in here. So probably the easiest way to do that is copy, create, probably just to sketch, draw that line. You see right there, I'm getting that dot, dot, dot line come down right in there. If I come up right here, draws me that nice dotted blue line so long as I stay somewhere close and give it a chance. If I come in here, it should pick up on that and give me a, well, we'll fix that up and I'll come right down there and put that together. Now there you can see not parallel. I can say I want these two to be parallel. That squares that up. I can tell it that I want, where's my right angle? Well, I guess I can also say parallel. I want this one to be parallel to that one. That's already applied. Okay, and then we've got perpendicular corners right in there. So now it's just a matter of putting some dimensions on here, telling it to make that 3 millimeters, and we'll put this 5 millimeters in from, and just pay attention to where this is going right here, because we should have, there we go, an edge that we projected in there somewhere, and set that 5 millimeters back. And this should have taken a lot of its dimensioning right off of that side right there. Okay, so now we've got a couple of holes in there. We're just going to come through here and we're going to punch them out. So go ahead and do an extrude. Oh, finish sketch. And extrude. Take those two holes. And they're going to go minus 3 millimeters. And they are going to cut. And let's make sure they're cutting right through there. Perfect. So now we've got a couple of gaps coming right through there. And let's make some nice matching gaps up on the top of this side right here. They're going to come right out to the edge because they'll be mirrored as well. And that will let us slide a couple of spacers right in here, just to keep things from wiggling around in the vertical direction. By the time you put a bit of glue on them, it should hold everything together fairly nicely. You may even want to add another spacer right on that side, and then you'll have a fairly rigid box holding everything apart. But just that one by itself, probably not enough to hold things together. It's nice to have the slots pre-cut to put things in. You'll find that with the laser, we get really, really fine kerfs. And in my experience, most of the MDF we've got, when it says 3 millimeters, if you tell the laser to cut a 3 millimeter gap, the MDF will fit in there. But if you've got a different material or you're not sure, get out your calipers or your micrometers and measure the actual thickness of your material and make a couple of test pieces first. Because if you're a 1/10 of a millimeter off, it can be a royal pain in the butt to get your pieces to fit right in there. Okay, so we got a couple of gaps right in there for spacers to fit into right here. And now what we're going to do is we are going to create a new drawing. And I think we'll create that new drawing on this plane right here. Right there. Okay, and what we're going to do is we are going to project. And what we want to do is just zip off to this side right over here, and we want to project that surface right down there so that we can make our rectangle in here line up with that. And because we are working on a parallel surface now, I can switch over and I can use a rectangle tool And I'm just going to line that up right there, bring that over to right there, and another rectangle right there, and line it up right there. You can see that we are digging off all those previous dimensions we put in, so the pieces that we fit in here should fit quite nicely. Okay, and now I'm just going to take that and extrude that piece and that piece, and we will extrude them -3 millimeters. Okay, now normally this would be really weak. Remember, we are going to mirror it about this plane, and we are going to have some wood in there gluing it all back together. If you were concerned about that, of course, we could have 2 finger joints joining things together, but this is probably going to be good enough. Okay, so now let's come in here and we are going to create a sketch. And this one, we're going to get fancy and create it on this plane right here. Now that kind of just flips this around, and it's a little bit hard to see where we're working on right now. We're on one of these planes right in here. So what we want to do is, let's see, if you're unsure, just ask it to draw a line, and you can see there's the plane that we're working on right now is right down here on that surface. So what we want to do is we want to project a couple of profiles in here so that we're able to build a piece on that profile to match up with what we're going to need. And we are going to project that piece right there, okay, because that's one of our holes for a flange. And that piece right there, because that's one of our holes for a flange. And that should pretty much do it. Do we need, yeah, let's see. That should do it for us. I think we've got those 2 projected onto there. We can see in right there. So let's go ahead and let's draw a box. We're going to come from right here, and our box is going to come right over to right there. Now that doesn't have our flanges on it yet. Then what we can do is we can come in here, we can draw another box from here up to right there. That's going to have that flange on it. And then we're going to come in here and we're going to draw that one right in there, and we'll finish that sketch. And now we can go ahead and we're going to extrude this. Make sure you get all 3 surfaces. Tell it you want to extrude 3 millimeters. It already had that figured out. And instead of joining it, we're going to create that as a new component. And oh, did it forget to include that piece right up there? If it did, yeah, we've only got 2 selected. So come in here and under your select, just add that piece in. There we go. And we will go OK. And now we have that piece tucked in right there, and that's going to be solidly wedged in place to keep these parts from rattling and rolling apart. And you can then come in and do the same thing down here. It should be pretty much the same profile. Create a sketch right here. Okay, project. That right there. That surface right there. So we've got those 2 surfaces as references. Okay, oh, did we get that projected? Create, project. Usually I have to tell it I'm done projecting when I'm done. So there's 1 selected. Oh, that was it. I think I have to do it twice on here. Project. Okay, I probably projected them 4 times over. Let's just come in here, and we can come in here right now, and we can draw a box, and that box can go from there to there. And then we can draw a box from there to there. The project probably already built the box in there for us, but let's make sure we've got that. Well, did I get those ones? I didn't quite get those lined up. So if I want to make sure that those are lined up, just go coincident. Oh, sorry, these are lines. We want them to be collinear. Somewhere in here, there is a collinear. That line should be collinear with that line. Make sure they line up right at the bottom right in there. That's looking better. And finish sketch. And now we are going to extrude this piece, and that piece. Well, it looks like there's a little flaw right up there. I was getting a bit sloppy. Okay, if you see something like that and it doesn't look like it should, cancel what you're doing and come back and check out your sketch. That sketch is going to be right in there. Come and edit that sketch and find out what the heck just happened right in here. And that line right there needs to be, oh, sorry, got to go back into sketch mode. There we go. That line right there needs to be collinear with that line right there, because otherwise that's not going to fit when you come to put it all together. Finish sketch. Always fix the weird stuff when you get a chance. Don't let it build up on you, or it just keeps on compounding. Okay, and we don't want to join that. We want to have that as a new component. And there you see it comes in blue and it fits through there nicely. Oops, looks like we're missing that surface right there. Click on that. Make sure that you fill up all those gaps. And that's looking pretty good. We've got some webbing in there. That should hold that nice and securely all together in there. And we can probably do the same up here. Maybe we'll get away with just doing one piece right in the middle because I don't think there's quite as much load going to be up here. But if you just have that sitting there without anything to brace it, it's going to wobble and it's going to fall apart and it's going to be a weak point, even if you put a ton of cyanoacrylate glue on it, because you've just got a tiny little butt joint right in there, and that's not doing you much good for anything. So again, it doesn't take long. Create a sketch on the surface right here, and yeah, make one, make two. Let's just set it up right in here and dimension that. Oh, sorry. 3 millimeters. Oh, I forgot to make that collinear with that side. Bang, that comes in there collinear like so. Dimension from that side to that side. Let's only have it off by 5 millimeters or so. And we can finish that sketch. We should position it somewhere in here in the middle. Let's go 25. That looks middle-ish. Okay, and let's finish that sketch. And let's extrude that piece. -3, we're going to cut right through to create a gap. Okay, now we're going to create a sketch on this side right here. And oh, this is another one of those ones that's off at a funny angle, so we're going to use the line instead of the rectangle before we do. Let's do a project just to make sure that we've got that surface projected as a reference. You can see those dots appear right in there, so we can come in here and we can come up, and I'm just going to bring it to the inside a little bit. And I'm not going to come up very high. I'm going to come over here and bring that piece up. Oh, I clicked on, oh well, clicked on the check mark instead of the instead of the line that I wanted. So I come up right here. There we go. There we go. Join all that together. Okay, we're not parallel up at the top. We want that to be parallel. So we just tell it, I want this parallel to that, and I want this parallel to that. There we go. That squares everything up in there. Those are already perpendicular to that slot in there, so our piece of MDF should fit in there just fine. We need to give it a dimension on here. Oh, that's already determined by the one below that it's 3, so we don't need to give it a dimension. Let's maybe give it a dimension. From there to there. Let's set it back by 5, and let's make this again. Let's bring that in. Now 12, make it about half an inch long. That should be fine right there. And now we'll finish that sketch. And we'll do an extrude of -3. Okay, so now we've got a gap here and a gap right there. And let's come down and, oops, create a sketch on that surface right there. We will project and include that surface. We will project and include that surface. And we will draw a rectangle from, there we go. See, I wasn't careful about getting those two lines. See that little blue line, the dotted line in there? That's what I slacked off on last time. We'll bring that out to right there. We want it to line up with that piece and come up a little bit past there so our finger digs in. Okay, we can, you know what? I think my projection is going to give me enough to get that surface in there. I probably don't need to double project. So let's do an extrude, take that surface, and yes, those projections came through. Extrude that out 3 millimeters, and we are going to create that as a new component. And it comes in a nice bright color in there. And there we go. We've got these little webs coming together. And if we cut them all out on the laser, they'll pop in like that, and they will mirror everything together for us quite nicely. Now, one of the things that we can do to make our arm a little bit lighter is we can come in here and we can remove some material in here. And there's all sorts of ways to remove material. But if you want to get fancy with it, what you can do is you can come in here and let's create a sketch on this surface. Now you could totally truss your arm out, but you can also come in here and create a sketch on this surface. And if we're going to put a sketch right there, we can create text. And let's just come in right here. And so long as we don't cut into any critical parts, there we go. What angle do we want it at? Text. Let's just see what it's going to say right on here. BCIT. Now make sure you choose a suitable font, okay? Because if I cut BCIT out right there, I'm losing the middle of the B. So you might have a stamp font in your system, and some of the stamp ones are pretty good. Oh, PQR. Pretty sure it was called stamp. Stencil, I think, was the. There we go. And you can see stencil leaves those pieces behind a little bit. And I'm going to increase the height up by 30. Oh, let's go 30. Reposition that a little bit. Now, there we go. I'm coming in from the outside of the arm, so I don't need that to be mirrored. That's going to come in right about like so. It shouldn't interfere with anything else that's going on in there. And so I am going to say OK. And that creates a profile, and you can take that profile and you can do a finish sketch. You can go extrude and -3 millimeters. And that's going to be a cut, and go OK. And now you've cut that part out of your arm right there. Like I say, you can go through and you can build trusses in there or whatever fancy techniques that you want, but make sure you use a font like stencil that doesn't drop your middle pieces out, because they're really hard to put back in. Okay, so now we have exactly half of your piece all put together, and you'll recall that we made a mirror plane earlier on. Now that I think about it, we probably didn't have to do that. We could just use this plane right here. So what we're going to do is we are going to create, and we are going to mirror, and we are going to mirror our components. Okay, and we are going to select them all. Okay, right there. And then our mirror plane, we do have a plane set up that we can already use, but since we made that 22 millimeters, we can come in and we can flip that together and mirror that around. Oh, just realized that text came in backwards. So before I do the mirroring, I'm going to cancel that mirror. I'm going to undo that extrude on the text. You can put the text in later. If we'd done anything other than text, if you'd turn this into a truss or something like that, it would work perfectly fine. Okay, but we ended up with a mirror image of the text. I was hoping that it would flip around and take care of itself. Mirror. I want to select. Oh, why am I'm back in sketch mode. Oh, because I was removing that text. Sketch palette, let's get out of that, undo that. Back here, we're back into our main object mode. That's all set up. Create, mirror. We want components to mirror. 1, 2, 3, 4, 5, 6 components. 6 are selected. Pick on the mirror plane, and any one of these surfaces, if we've drawn it right, should work out fine. And we go OK. And there we go. Now, this is where having all those colors turned on comes in useful, because we need to join a couple of these things together. So obviously these two parts don't get joined together, but this gets cut out as one part. We don't want it getting cut with that line right down the middle. Let's just check and make sure. There you go. You can see where that slots in right there to hold everything together. You can see where these slots come in right all in there. And yeah, so just in case you're wondering where those colors came from again, that was under Inspect, Component Color Cycling Toggle. This is what it looks like with them off. Okay, and so Inspect, Shift-N will also do it for you. Lets you see how things come together. Okay, so now what we want to do is we want to combine some of these components, and we have a tool for doing that. Let me just figure out where it went to. Modify, move copy where, press pull, fillet chamfer, combine. Okay, and we want to take that one and that one, and we want to join them together. And okay, that's one component now. We'll zoom in, modify, combine. That one, join together into one component. Modify, combine. Okay. Then we just need to finish up our pieces up here. Modify, combine. Where did it go? Okay, and modify, combine. Okay, so that should enable us to put that all together. You can see how this is going to, the laser would end up cutting out 1, 2, 3, 4, 5, 6, 7 pieces for us right there. And those 7 pieces would fit together like a little jigsaw puzzle with their various slots. And that should hold our arm relatively solidly together. Now, what's kind of cool is that you can come in here and for the whole thing, you can assign some properties to it. So for physical material, you can come in here and under wood, you can come down here and tell it, that was a right click on the material, and then physical material, tell it medium density fiberboard. Okay, now didn't change anything ridiculously. You could see when I put the aluminum on it that changed the surface finish, but MDF didn't really have a surface finish on there. But now when we go inspect, oh sorry, not that, when I right click right here, and I should be able to come in here, and there is a selection in here. Appearance, we go properties, and this tells me a whole bunch of things about the material, most importantly, the mass. And that's telling me we've got about 546 grams of medium density fiberboard right there. So, so a half kilo. Again, if you truss it out, you can probably remove about 70% of that material without any problem. Most of it is redundant. Right in here, we probably don't need this much material. You can chop something out of the middle of that. So now that we've got that put together, make sure you hit the save key. Okay. And now we've got that saved. And what we want to do with this is ultimately we want to start turning this into an AutoCAD drawing, because you can use AutoCAD to drive your laser cutter. To get the profiles for cutting these parts out of your laser cutter is fairly simple matter. All that you need to do is create a sketch on any surface. So anytime you've got a flat surface in Fusion 360 and you want to extract the profile of that sketch over to AutoCAD, you can just click on that plane to create that surface right there. And you'll see that a new sketch pops up right over here. And you can come to the little drawing right here, and I'm right clicking on it, and I'm going to go save as DXF, and that DXF file, store it in a folder somewhere, because later on you can take all of your DXF files, import them into AutoCAD, put them together onto one drawing, figure out how to nest them onto a single sheet of 18 by 24, because the laser cutter we're using at BCIT is 18 inches by 24 inches. So you want to get your pieces tucked away neatly onto there so you can get as much as you can out of one sheet of MDF. Make sure their line weight is correct, and you'll be ready to go. These parts will make themselves. If you've got all your joints set up just right, they'll go together and they'll work beautifully. So come in here and export that profile. You'll need 2 copies of it, but it's the same profile on each side unless you've added something unique in the way of trusses or lettering on that side. You'll need to come in here and you'll need to take this surface. And again, what you'll want to do is finish your sketch right here, and you can undo that step once you're done. You don't need to leave this sketch in your profile file, but you can if you want. Come in here, create a sketch right there, sketch number 15, and just go in there and I clicked on the wrong thing. I turned its visibility off. Sometimes you have to hunt around. You got to click on the right thing right in there, but a right click in there will get you a save as DXF. That profile will come out right there. Okay. You'll need 2 of this profile, 1 of that profile, and 1 of that profile. And that should bring everything together, and you should be able to start laying that out into AutoCAD right now. Don't spend too much time getting it all perfectly arranged because you are going to have more parts to add into that. But if you've got that all sitting on a sheet of paper or on a sheet, then you can walk into the laser cutter room, press go, and in about 15 minutes you'll have every part that you need to build this arm sitting there. It goes from, the assembly part is like making a jigsaw puzzle. So this is how to make your boom. Okay, making your arm is exactly the same thing. So, oh, this is brightly colored now too. How nice. So we just went and made the boom right here. Well, you want to come out and you want to make the arm. Now, as you can see, I made it out of sheet metal and used just a couple different techniques to do that. But for my assembly path, I'd end up taking this piece and you can lay that out flat. And so you can get a flat pattern profile, and then you could either print that on a piece of paper, glue it onto a piece of aluminum, cut your aluminum, fold it up, or I could take that profile path and export it to a plasma cutter or water jet or metal cutting laser. If you happen to have one of those kicking around, let me know. I'd love to have access to one. And then you could go ahead and you could get that piece cut out really easily. I'd probably even put a couple little fold marks right along here and just cut a couple little slots right in there to make sure it bent at exactly the right spot. Anyways, you're going to use the same technique that you use down here to make a piece right up here for the laser. Now, a couple of things to keep in mind when you're looking at that is that you're going to be using a profile something like this, and you can see that right in here, the syringe is occupying space inside right here. So you can't put any of your braces or your pivots too high up right in here. You might be able to get away with something right down here. You could try seeing how low that comes. You can probably put a brace piece right inside here. You can probably get a fair bit of bracing up and down right in here. Maybe a piece right along in here somewhere, but go ahead and design your own parts. It's going to be the exact same technique you used for using the boom right in here, and see if you can design your own arm. Again, you do have to take a look at this and just make sure where's everything fitting. You probably don't want anything getting in the way with movements right inside here. Those of you who have some other ideas and you're saying, well, why is he doing it all on the laser? You're absolutely right. If you want to model it differently, and you'll recall in the drawing that I showed you right at the very beginning, I was saying, well, why couldn't you just use two pieces of plywood, two pieces of 3/4 inch, 19 millimeter plywood in here would give you a nice 38 millimeter gap. And 4 pieces of 7/16 ply down here, they're about 11 millimeters each, would give you a nice 44 millimeter gap across there. You could model those pieces, put them in and put them all together. I think it's going to come out a little bit heavier than using the MDF, but if you're worried about there being a line on the laser cutter, that's a good way to turn this into a woodshop project too. And you don't need a laser either. I mean, these pieces right here, you could very easily cut out of MDF on a bandsaw, take 2 pieces of MDF, sit them on top of each other, hold them together, go down there and cut that profile out, drill a couple of holes in them, and you're going to be good to go. You don't need fancy tools to make this project. If you've got the fancy tools, however, you might do things like, instead of building the jigsaw puzzle like we did for arm, why not just make turn a round spacer, take a piece of piece of nylon or something like that, throw it on the lathe if you're in the metal shop, and just bolt right across there with a solid piece of nylon, a cylindrical spacer running right across there, or 3D print a spacer if you're working out of the drafting lab. You've got all sorts of options on how you're going to go about assembling it. I've got sheet metal here. I just showed you how to put together a laser cut jigsaw type piece, but there are so many other ways to put things together. You're not wrong to go out and explore. And as much as I can appreciate your sense of frustration at getting dug down a hole of headbutting and trying to figure out how to make the software work, sometimes you end up finding really neat things as you go exploring in there. For instance, I found out how to make everything turn nice, pretty colors so that you can tell which component is which. And the only way you learn this stuff is by doing it. And if you're in a little bit of agony while you're going through there, stick with it. Okay, it's like running a marathon or something like that. That the finish line is usually on the other side of some of that agony. Have a great time, and I look forward to seeing your arm work. You may not know it, but this is really, really cool stuff that we're doing right now.